morning and welcome to Challenger Connection number 19. I'm missing Commander Jennifer today, but she's having a lot of fun doing her videos with Commander Sydney. And I want you to make sure that you listen to my next video on Monday for a very, very important announcement. We're very excited about a special guest that we're going to have on Challenger Connection. But today we're going to talk again about density. That's one of my favorite subjects. We've done foil boats and we did the raw eggs floating in salt water. We did the oranges peeled and not peeled. So we've done a lot about density. And today we are going to make something called a density column. And this is my favorite density experiment of all. So let's remember what density is. Density is the measure of how much mass is contained in a given unit of volume, okay? So if a mass is a measure of how much stuff is in an object or a liquid, we're gonna be dealing with liquids today, then density is the measure of how tightly that stuff is packed together. So every liquid has a density number associated with it. And I know we mentioned when we were doing the foil boats that water has a density of 1. So I picked 5 different liquids from my kitchen. I had to wait actually to do it today because one of the liquids I didn't have any, but I got it in my Kroger takeout order this morning. So they brought it out to my car and I have that now. So let's go over our liquids. And remember, water has a density of 1 gram per milliliter. So we're going to start on this side, and you'll notice I've colored some of this liquid. This is actually rubbing alcohol. Rubbing alcohol is something you might put on a cut to clean it, or it's, again, the main ingredient in hand sanitizer, so we know that this is flammable. Remember that word. That means it can catch on fire. So I dyed my rubbing alcohol red. It doesn't really matter what color. Just use a couple drops of food coloring. Then next I have this yellow liquid. I didn't color it. It's actually its color that it comes in. And that liquid is actually vegetable oil. Something that you would fry French fries in. Okay. Then I just have some water. Remember, water has a density of 1. And I colored my water kind of this green. I just put a couple of drops of food coloring in. Then this is a really pretty blue. I didn't color it, but it's actually Dawn dish soap. And I had some of that on hand. And the thing I had to get in my Kroger pickup order this morning was this light corn syrup. Now notice it's more of a kind of a clear color, but I went ahead and colored my corn syrup blue so we could see it better in the density column. So let's talk about the densities of these liquids. We know that water has 1, the density of 1 gram per milliliter. Alcohol, rubbing alcohol, has 0.79. Vegetable oil has 0.92. And Dawn dish soap has 1.06. And light corn syrup has 1.33. So those are the densities. So all these liquids have different densities. So what we're going to find out is what happens when we put these liquids all together in a column, in a container. And I just have a glass base. You could use a glass, just a regular glass that you drink out of, a jar, a pickle jar, anything that's clear that you can see through. Now, I also pulled the salad dressing out of my refrigerator, and you can look and see that this salad dressing is layered. There's oil on the top, there's lots of herbs and spices in the middle, and then you've got water and vinegar on the bottom. That's because everything in this salad dressing has different densities. So if I was getting ready to eat my salad for dinner, I wouldn't just want to pour the salad dressing on my salad without shaking it up. And now you can see everything is mixed together for just a little bit. But as that salad dressing sits, because of the different densities in those liquids and solids in there, everything is going to separate back out again. So let's build our column. Now you noticed we're using some liquids that aren't liquids that I would want to get in my eyes or on my face. So I'm definitely going to use my goggles, especially because of the rubbing alcohol and the Dawn dish soap. Those wouldn't feel very good. So put that on. And now let's make our column. All right, everybody, are you ready to make our density column? The very first thing we're going to add is our corn syrup that we dyed blue. So remember, the corn syrup, the light corn syrup, has a density of 1.33. So when you're dumping this in, you want to make sure you go right down the middle. You don't want to get it on the edge too much. And you can see our column has our first layer. Now, sometimes using a turkey baster is helpful, but I don't have one. So I'm just going to have to be super careful when I dump in my liquids. All right, I think I'm going to do the Dawn next. So the Dawn has a density of 1.06. So technically it has less density than the corn syrup, so it should stay on top of the corn syrup. And I just thought about my two blues kind of maybe looking the same in that column, so we might have a lot of blue there. All right. Now, water has a density of 1, so let's see what happens. And you kind of want to go really slow. Not too fast. And now you can kind of see the green separated from the blue. Now, water has a density of 1. Vegetable oil has a density of 0.92. Now, when you ask people, will oil sink in water or float in water, a lot of people will think it will sink. But oil actually floats. And that is one reason we can clean oil spills in the ocean just a little bit easier, because that oil will come to the surface and can be scooped up. So look at that. Water there. Okay, so I'm getting some different colors. Kind of got my blues and kind of have my greens and kind of have my yellows. And now I'm going to do alcohol, rubbing alcohol, 0.79. So I do kind of wish I had a turkey baster, because I think it would be a little bit less mixed up. And so what'll happen is if we let this sit for a while, and you can see it's starting to separate. I got to mix a little bit when I poured in, but if we let this sit a while, we should get a very colorful column. So another fun thing you can do is to check the densities of solid objects in your density column. So I randomly picked some things around the house, and I'm going to put them in the column and see if they all sink to the bottom. They might float in the middle. It will depend on how their densities compare to the densities of the liquid in the column. So I want you to do that also. Find some different things than I did. First thing I'm going to do is drop a nickel. And it looks like the nickel is floating in the oil. Let's see what a penny does. Oh, the penny is floating right under the oil. And then we have a shell. Let's see. That shell looks like, well, where did it go? Then we have a piece of cork. And of course, that piece of cork is floating right on top. And then I also got a rubber band. And notice that rubber band is going down to the dish soap. So let's look and see where things are. Oh, the penny and the nickel went all the way through the corn syrup. You can see it down there. And the cork is floating on top. The rubber band is sitting on the corn syrup. And let's see if I can find the shell. I think the shell is floating right there. So try a paper clip, try a thumbtack, different things around the house, and see what floats in what liquid. All right, everybody, I had a great time today making density columns with you. Make sure you post your results and pictures in the comment section below this Challenger Connection. Don't forget to watch Commander Jennifer and Sydney on Friday, and stay tuned for Monday. Make sure you watch me when I make a special announcement about our special guest. This is Commander Melissa, over and out.